Hello friends, in this video we will try to represent the given signals, these two signals, in the form of the ramp functions and unit step functions. Okay, so first let us try to represent the given signal y of t in terms of ramp functions. Okay, so before we proceed, first we should know the equations of the straight lines given here, which are given by, so this equation would be t plus 1 by 2. Equation of this straight line would be t plus 1 by 2, because at you can verify that by substituting -1 you should get 0, and at 1 you should get half, at 1 you should get 2. In a similar fashion, equation of this straight line would be 3 minus t by 2, and finally equation of this straight line would be t minus 7 by 2. Okay, so we will try to represent this whole signal y of t in terms of the ramp function. So just to start, so if you look at the given signal, so let us write it as y of t. So our signal y of t would be equal to, so initially the signal starts at -1, and we at -1 we get a positive slope of half, and this continues till 1, and hence so y of t would be equal to t plus 1 by 2 times, and because this flow starts at -1, so you will get u of t plus 1. Okay, so that is the first step. And at +1, what happens is that the initially at +1 the slope changes from 1 by 2 to -1 by 2, and hence we should add a signal with a slope of -1 at -1, and hence we will get minus of t minus 1 times u of t minus 1. So why is this correct? Why? Because initially at -1 the slope of the signal is half, and after -1 slope of the signal is minus half, and hence we should add a signal with a slope of -1 to the signal before 1. So and hence, and because it starts at +1, you should have u of t minus 1, and this continues till 5, and at +5 what happens is that the signal slope again initially it is minus half, and at +5 the slope will become plus half, and hence what should we do? We should add a positive t at 5 into u of t minus 1. Okay, and at 7 what happens? And 7 again the signal is a flat signal, means you should have a zero slope, and hence what should you do? We should finally subtract minus of t minus 7 by 2 into u of t minus 7. So this represents our first signal, and clearly this can be written as 1 by 2 times r of t plus 1 minus second fellow would be r of t minus 1, and third fellow would be r of t minus 5, and finally fourth fellow would be minus 1 by 2 times r of t minus 7. Okay, so in that way you can represent the first signal in terms of ramp functions. So let us come to the second one. So clearly first step is we should represent the slopes of the straight lines given here. So equation of this straight line would be t plus 1 by 2 as usual, and equation of this line would be 5 minus t by 2. And again with the same process, let us represent this signal y of t in terms of ramp functions. Okay, and as discussed earlier, so the signal initially which is having a slope of 0 and at till -1, and at -1 what happened? The slope of the signal will become half, and hence you should have a signal in this fashion. It can be represented in this fashion: 1 by 2 times t plus 1 into u of t plus 1, and this continues till 1. At 1 what happens? The signal slope will become 0, and for this to happen we should add signal with slope minus half at 1, and hence you will get minus of t minus 1 by 2 into u of t minus 1. So and this process continues till 3, and at 3 what happens, this here the slope is 0, and after 3 the slope should become -1, hence we should subtract a negative slope, but this change of slope happens at 3, and hence it will become minus of t minus 3 by 2 into u of t minus 3, and this continues till 5, and at 5 what happens, the slope of the signal again becomes 0, and for this to happen we have to add a positive slope, and hence we should have positive slope, and hence this should be equal to t plus of t minus 5 by 2 into u of t minus 5, and this we can represent it as, this would be, note that every signal has 1 by 2 as a common factor, so this should be equal to 1 by 2 times r of t plus 1 minus r of t minus 1 minus r of t minus 3 plus r of t minus 5, and this is the way how we can represent the second signal. Thank you.